All right, so let's begin from question one. So question one, they're saying define the following. Okay, define the following, and then they've put even function and rational number. Okay, so what is an even function? So by definition, a function f is even, okay, if for every x in its domain, f of minus x is the same as f of x. Okay, so if this property here is satisfied, then the function f is going to be called as an even function. So a good example is f of x is equals to is equals to x squared. So you see that when you put x here, okay, as minus 1, you're going to get minus 1, and then squared, this is going to give you 1. Okay, if again you put f of 1, which is the positive x now, it's still going to give you 1 squared, which is 1. So we see that f of minus 1 is equals to f of 1. So since these two are equal, then this function here is going to be what? To be even. So that's how you simply define an even function. You say a function f is even, okay, if for every x in its domain, f of minus x is the same as f of x. Right, so that's the definition there. And then the next thing is to define what a rational number is. So a rational number is a rational number, okay, is any number that can be written as a fraction. So any number that you can write in the form a over b or whatever variables you pick. Okay, some people they pick p over q. So any number that can be written in terms of a fraction, okay, where a and b are integers and the variable in the denominator or the number in the denominator is not equal to 0, we're going to be calling that as a rational number. Okay, so this rational number, when you take their decimal numbers, okay, when, for example, I do maybe 2 over 5. So this 2 over 5, when I put it on the calculator, okay, it's going to give me 0.4. So the rational numbers have decimal numbers that are either terminating or repeating. So repeating, for example, if you do 1 over 3, if you punch this 1 over 3 on your calculator, you get 0.333. So the 3's continue to go like that until Jesus comes. So the decimal form of a rational number is either repeating or it's what? Terminating, like this one. This one ends at 0.4, it ends, but this one continues to repeat like that, okay? So simply any number that you can write as a fraction, we are going to be calling that as a rational number. Okay, so I think I explained this in the tutorial sheet videos. Okay, so check out the tutorial sheet videos. I've already uploaded them there on the website. Okay, if you don't know how to find the videos, you can inbox me after the class. I'll show you how to find the videos on the mobile app or on the website. Okay, so those are the definitions. So if you have any question, just unmute yourself and then you ask. Otherwise, I'll move to question 2. So question 2, we have inequalities there. I can see inequalities. I can see we're testing if this function is even, odd, or neither. And then we have the alpha and beta roots there. So let's go over them step by step. So the first one, they're saying determine whether f of x, which is equals to x to the power 3 plus x is even, odd, or neither. Okay, so we said f is even if f of minus x is equals to what? F of x. This is what we said. Okay, so I'm going to add another definition here. F, okay, or a function f is called to be odd, okay, if f of minus x is equals to minus f of x. Okay, so we are going to test if either of those two properties are satisfied. So this is my f of x already. So let me find f of minus x here. So f of minus x here simply means wherever there's x in this equation, I'm now putting a minus x. So this will be equals to minus x and then to the power 3 plus minus x. Okay, because wherever there's x, I'm putting a minus x. So whenever you have a negative number being raised to an odd number like 3, 5, 7, any number that 2 cannot divide without leaving a remainder, then the answer that you're going to get from there is going to be negative. Okay, so this will be negative x to the power 3. And then this positive multiplied by the negative, I get minus x. Okay, so this is my f of negative x. So we compare it. Is it equal to this guy here? If we compare these two, are these two equal? Okay, we see that they are not. The other one has positives, the other one has negatives. So they are not equal. So we are going to say since, okay, since f of minus x is not equal to f of x, okay, then f is not even. Okay, is not even. So, but you don't end there. You test if it's also what? If it's also odd. So let's test for odd. So remember, for odd, we are following this definition. If these two are the same, then we're going to say the function is odd. So how do we find minus of f of x? We just multiply this f of x with a minus. So I multiply this side by a minus, it will be minus f of x. And then I also do the same on the other side. Okay. So you see that what I get is minus x to the power 3 minus what? X. So now look at what we found here. So if we compare this guy here, which is minus f of x, we compare it to f of minus x, we see that they are the same. Okay, because this is minus x to the power 3 minus x, even this one here is minus x to the power 3 minus x. So they are the what? Well, they are the same there. Okay, so since they are the same, we are going to conclude that that function is what? Is odd. So since minus f of x is equals to f of minus x, okay, f is an odd function. Right, so that's what we do there, okay? So if you're holding your phone in portrait, make sure you put it in landscape so that the screen appears bigger and then you can see properly. So any questions there? Oh, now we have tested that this guy is even or odd. Okay, so let's go to the inequality there then. So the inequality, they have said solve modulus of x minus 2 modulus and then less than or equal to 5. So how do we solve such questions? Okay, so the rule is that whenever you have something in modulus, let's say x and then modulus, and then if here you have a less than, or you have a situation where you have a less than or equal to something here, let's just say y, even here y. This here is the same as writing x, okay, on the middle, and then you say less than, and then this one here, you put minus y there, and then positive y. Even this guy here is the same thing. As long as you have less than there, or less than or equal to, it will be x less than or equal to, less than or equal to, you put positive y, and then minus y. Okay, so that's always how we're going to handle if such questions where we have a less than symbol and then with an expression which is in modulus in front of it. So this one here, okay, by this rule, we're going to say this is the same as x minus 2 because it's the one which is in the modulus, right? And then you say less than or equal to, less than or equal to. Then here we're going to put positive 5 and then there minus 5. Okay, so if you don't understand, please ask. Okay, and then from here, we're going to come up with two inequalities. Okay, we're going to come up with two inequalities. The first one will be this guy here that I'll put in blue. So this will be my first inequality. Then the other one will be this one that I'll put in red. So you've seen that I have two things there. So I have to solve two things in order to find the answer there. Okay, so the first one, let's erase this. The first one will be the one in blue. So that one in blue is minus 5 less than x minus 2. So we want to find the value of x, right? So we can say minus 5. This minus 2 goes to the other side. So it's plus 2 less than or equal to, and then I have x there. Okay, so this means minus 5 plus 2, that is 3 less than or equal to what? To x. Or you can write this as x is greater than or equal to what? To 3. So this here will be the first set of answers for your x. Okay, so any number that is equal to 3 or greater than 3 is going to work here. Okay, it's going to work there if we try it out. Okay. All right. So all right. Okay. Let's see if there's a restriction. If we find the answers for this one. So this one now, it is we're solving the part which is in the red circle. So that is x minus 2 less than and then 5. So this will mean that x is less than or equal to uh, say 5, and then the 2 goes to the other side. That is plus 2. So x is less than or equal to what? To 7. Okay. So we have found two answers here. X is less than or equal to 7. Okay. X is less than or equal to 7. And then we've also found that x, in fact, here this was minus 3, right? So you guys are not telling me. Because look at this number here. This is minus 5 plus 2. So this should be minus 3. And then even there should be minus 3. Okay, so here we have found x is greater than minus 3. And then here x is less than 7. So that means that x will just be between the minus 7 and the minus, I mean the positive 7 and the minus 3. So I'm going to write x, okay? We've said this x is less than 7, right? And then from this one, we said x is greater than minus 3. So the greater than part will be where the x is. So x is greater than or equal to minus 3. Okay, so this one here is the set of solutions that are going to work here. So whenever you get a number which is from minus 3 to 7, okay, you put it there, the equation is going to what? It's going to work. So for example, let's take maybe 0, because 0 is between there. So if I do 0 minus 2 modulus, this is less than 5. This will just simply be modulus of minus 2 less than 5. Modulus of any negative number, it's positive, which is less than what? 5. So it works. So any number between minus 3 and 7 is going to work in this inequality there. Okay, so any questions there? Okay, so let's look at the roots of quadratic equations now. So here they're saying if alpha and beta are the roots of x, y squared minus 2x is equals to 5. Find the value of 1 over alpha plus 1 over beta. And then 2, they're saying find the equation whose roots are these. Okay, so these ones here are very simple questions, guys. You should not fail questions on the roots of quadratic equations. Okay, so we know that we have two roots, alpha and beta. So you just have to know how to find their sum and also how to find their product. Okay, and then another skill that you need to have is to summarize, okay, or manipulate any type of roots that they're going to give you into their sum and their product. So here we know that alpha plus beta is equals to, okay, minus b over a. And then alpha multiplied by beta is equals to c over a. So where do we get this ABC? Okay, so remember the general form of a quadratic equation. It's like this. Okay, so the a is the coefficient of x squared, the b is the coefficient of x, and then c is the constant. So from this equation here, I'm going to write it in standard form. It will be 3x squared minus 2x. This is 5. I'll take it this side, so it will be minus 5 is equals to 0. So you see that now the a will be this 3 here, the b is the minus 2, and then the c is this constant here. Okay, so let's find the sum and the product of these roots. So alpha plus beta is going to be equals to minus b. So b is minus 2 divided by a. A is 3. So this is just going to give me 2 over 3. Okay, and then alpha multiplied by beta, this will be equals to the c, which is minus 5. Okay, divided by 3. So this will just be minus 5 over 3. So this is the product and this is the sum. So now we want to find the value of 1 over alpha plus 1 over what? Beta. So we want to express these roots here, okay, in form of their sum and their what? Their products. That's the only way we can find this answer. So I'm going to say common denominator here will just be the product of these two. So it will be alpha beta. So alpha into alpha beta, I just get beta. Okay, plus beta into alpha beta, I just get alpha. So that will be alpha. But we know from binary operations that addition is what? Commutative. So what I have on top, I can write it as alpha plus what? Beta divided by alpha beta. So we know the value of alpha beta. It's 2 over 3. And then I'm dividing that by the value of alpha multiplied by beta, which is what? Minus 5 over 3. So we see here that this is going to be 2 over 3 multiplied by this one switch. So the 3 goes up, the minus 5 goes down. I have minus 3 over 5. Okay, and then from here we see that this 3 and this 3 is going to cancel. So here I'm remaining with 1, even here 1. So I'll multiply 2 multiplied by minus 1, I'll get minus 2, and then 1 multiplied by 5, I get 5. Okay, so this here, the minus 2 over 5, that is the value of 1 over alpha plus 1 over what? Beta. All right, so any questions there, guys? Okay, so if you have no questions, but you need more practice questions, I'm sure I sent the video for you guys in the group. Okay, I sent the video. Is it yesterday when I sent the video on the alpha and beta roots? So make sure you also watch that video, because in that video, there are many practice questions. So you can go through them so that you really understand the concept. Or if you want, just go on the app. Okay, just go on the app, Discrete Learning Institute. You're going to find a folder full of videos on what? On alpha and beta root. So you can learn anytime, anywhere. You don't have to wait for me to teach you, for you to learn. The videos are already there. You can be learning anytime that you want. 04, 03, 02, you can still learn. Okay? I've even remembered that story for that one who was robbed. 02. Wanyang'anya kudo. Yeah, so you can actually learn anytime. Okay, so there are a lot of videos on alpha and beta roots. So check them out on the website or on the app. Okay, but I'll also share a video in the registered group. So that's the value of this thing here, minus 2 over 5. So now let's find the other one there where they're saying find a new equation whose roots are that. Okay, so the new equation, okay, is always in this form. Is always alpha, I mean x squared, okay, is always x squared, and then, okay, it's always x squared minus, okay, the sum of the roots, which is alpha plus beta x, okay, and then plus the product of the root, which is alpha beta, is equals to 0. So always the new equation is in this form. But where are you going to get the alpha and beta and the alpha multiplied by beta? From the roots themselves. Okay, so in fact here I should not have written alpha and beta in the equation. So I just have to write the sum, because they can differ. Okay, so sum of the roots that you are given like that, and then plus the product of the roots that you've been given is equals to 0. Okay, so this one is now the correct one. So sum of the roots that we've been given there, we're just going to add these two. So it will be alpha minus 2 plus beta minus what? 2. So this will just give me alpha plus beta, and then minus 2 minus 2, that will be minus 4. Okay, but we know the alpha, we know the value of alpha plus beta. This is what we found here. So I'm just going to put it there. So 2 over 3 minus what? 4. Okay, so over 1. What do I get when I combine this? It will be common denominator is 3. 3 into 3, 1 multiplied by 2, 2 minus 3 into 3. That will be 3. I mean 1 into 3, that would be 3. And then 3 multiplied by 4 there, that is 12. So this is just going to give me minus 10 over what? 3. Okay, so this is the sum of the root. So sum of the root here, we're going to put minus 10 over what? Over 3. All right, what about the product of the roots? Product of the roots, we're going to multiply them. So I'm going to say product is equals to, so I'm multiplying these two roots here. So it will be alpha minus 2 multiplied by beta minus 2. So this will be alpha multiplied by beta, alpha, beta. Alpha multiplied by minus 2 alpha, minus 2 multiplied by beta, minus 2 beta. Then minus 2 multiplied by minus 2, I get plus 4. So this one here, you see that the things that I have on the middle there, I can factorize a minus 2 so that in the brackets I have alpha plus beta. Okay, and then plus 4. So this is what I have here. Okay, so from now then, we're just going to substitute the value of alpha multiplied by beta and the value of alpha plus beta. So the values, we have them there. So let's just substitute now. Okay, so that is the sum and then that is the product. So I'll say product is equals to alpha multiplied by beta is minus 5 over 3 minus 2. Alpha plus beta is 2 over 3 and then plus 4. So this will just be minus 5 over 3. Then this minus 2 multiplied by 2 gives me minus 4 over 3 plus 4 over 1. So this will just be 3. So 3 into there, it's 1. So minus 5 minus 3 into there, it's 1. Multiplied by 4, I still get minus 4 plus 3 into 3, that is it. 1 into 3, that is 3. And then 3 multiplied by 4, that will be 12. Okay, so on top I have a minus 9 plus 12. Okay, minus 9 plus 12, that will just give me 3 divided by 3, which will just be 1. So the product here is 1. Okay, so we found the sum, we found the product, and then finally we can write the new equation whose roots will be alpha minus 2 and then beta minus 2. So it will be x squared minus, the sum there is minus 10 over 3, and then x, and then plus the product, which is 1, is equals to 0. Okay, so this is the equation here, but never leave your equation as a fraction. Okay, so I have to get rid of this 3 in the what? In the denominator. So what am I going to do? I'll multiply throughout by 3. So 3 multiplied by this, I get 3x squared. 3 multiplied by this, okay, the 3 and the 3 cancels out. So I remain with minus, okay, outside here multiplied by the minus 10. So I get plus 10 and then the x there. And then plus 3 multiplied by 1, that is 3, is equals to 0. Okay, so that is the equation whose roots are alpha minus 2 and then beta minus 2. All right, so any questions, guys, on how we've done this? All right, so let's move to part C. All right, so part C is on expressing repeating decimals in form of a fraction. Again, the tutorial sheet has been solved. It's there on the website with more practice questions, so you can check it out. So here they're saying express 3.532 with a bar on top there in the form a over b, where a and b are integers and b is not equals to 0. Okay, so the first step there is just to say let x be equals to the number that you've been given there, bar. Okay, so from this number here, where we want to find two numbers such that immediately after the decimal point, the repeating part comes. So this one here that has 532 bar on top, it actually means that 53 keeps on repeating. So in other words, I can write this number as 3.532, 532, 532, 532, 532 until Jesus comes, because this guy here continues to what? To repeat indefinitely. Okay, so mathematicians are very clever people. They said, why should you waste time and strength and paper? Okay, so if a number is repeating, we're just going to be putting a bar on top. So that's what it means here, of this 5, 3, and 2 to have a bar on top. Okay, so that is our x. So we want to find another number, okay, because this one here is already a very good number. So I want to find another number such that immediately after the decimal point, I have the repeating part. So the first one is this same one, because I can see it's 3.532 with a bar on top. So the repeating part comes immediately after the decimal point. Okay, so now I just have to get another number. So that number, I'll get it by moving this decimal point. So I'll move it 1, 2, 3. Such that the position where I'm putting the decimal point here now, okay, after the decimal point, I have the same repeating number like that. Okay, so to move the decimal place 1, 2, 3 times, I have to multiply by 1, and then I add um, zeros, okay, equal to the number of steps that I've made. So I moved 1, 2, 3. So I'll add 3 zeros like this. So I'll multiply this x by 3. I'll get, I multiply this x by the 1,000. I get 1,000x is equals to, then when I multiply this part by 1,000, this decimal point is going to move 1, 2, 3. So the number that I have now is 3, 5, 3, 2 point, okay, 5, 3, 2, 5, 3, 2, 5, 3, 2. The 5, 3, 2 still repeats. So I'll just write bar on top. Okay, so now once you have these two numbers, such that immediately after the decimal point, I have the repeating part, I'm just going to subtract them. So you subtract the smaller number from the bigger number. So the bigger one is this one with the 1,000x. So it will be 1,000x is equals to 3,532.532 bar. And then I say minus x is equals to, so make sure that the decimal point is in the straight line like that. So this will be 3.532 bar. And then you subtract. Okay, so the secret is that we're just trying to eliminate the part that repeats indefinitely. So this, I'll put the point there, but still, 5, 3 bar, 5, 3 bar, if I subtract them, they're the same thing. So I'm just going to get 0, 0, 0. Okay, so that should always be your goal, is that when you subtract these two numbers, okay, after the decimal point, the things should cancel out. You should have a 0. Okay, if you don't get a 0 on this part here, just know that you went wrong somewhere. And then let's subtract. So 3,532 minus 3, that is going to give me 3,529. And then here I have 1,000x minus 1x. So I get 999x. All right, and then from there, I'm just going to say, okay, I'm just going to say x is equals to 3,529 divided by 999. Okay, so is there any number that can go into those two numbers without leaving a remainder? Okay, so I don't think there's any number that can go into there. So this here will be our what? Our final answer there. Okay, so you can see x here was a decimal, but we've managed to change it into a fraction, which is in the form a over b, and we can see the b there is clearly not equal to what? To 0. So that's what they wanted us to do on part C1 there. So do you have any questions there? Okay, but if you have any questions, if you need more practice questions, they're there on the website and on the mobile app. You can watch, okay, how we are solving a lot of questions on this same concept here. All right, so if there are no questions, let's move to part 2. So part 2, they're saying solve the root of 5x minus 4 minus 3 is equals to 0. So this is a very simple equation, okay? We just want to move whatever does not have the square root to the other side, and then we square both sides. So it will be the root of 5x minus 4 is equals to 3. And then once you do this, you square this side and also you square this side. So when you square this one with the root and this guy are going to cancel out. So I'll just remain with 5x minus 4 is equals to 3 squared, that will be 9. So this will be 5x is equals to 9 plus 4. Okay, so 5x will simply be equals to 13. So x will just be 13 over what? 5. Okay, so that is my x there, if I solve for it. Right, so I'm sure there's no question here because this one is very simple. Let's look at the last one. So the last one, they're saying express 1 plus the root of 2 over 2 minus root of 2 in the form a plus b root of c, where a, b, c are real numbers. Okay, so here what they are simply telling us is to rationalize the denominator. That's all. That's okay. We're just rationalizing the what? The denominator. So I'm going to say let's multiply the numerator and the denominator by the conjugate of the denominator. So the conjugate is this same guy here, but with the opposite sign in between. So you can see here there's a minus, there I put a plus, and then I do the same on top. Okay, so this part here is just a special one because it's the same thing. Okay, we're dividing the same things there, so it's going to give you one. So it's a special one. So you're not changing anything on this equation here. Okay, we're just rationalizing the denominator. So it will be on top there, I have this guy here multiplied by this. So that is 1 multiplied by 2, 2. 1 multiplied by the root of 2 plus root of 2. Root of 2 multiplied by 2, that will be plus 2 root of 2. And then root of 2 multiplied by the root of 2, the roots are going to cancel. So we have plus 2 divided by, here, these are conjugates of each other. So for the conjugates, we said we are going to be using a shortcut. Okay, no need to expand everything. As long as two expressions are conjugates of each other, just have to square the first one. So 2 squared, that will be 4. And then you say minus, you square the second one. So if I square the root of 2, I'm just going to get 2. Okay, so on top, I'll have root of 2 plus 2 root of 2, and then 2 plus 2. So 2 plus 2, that is 4, plus 3 root of 2 divided by 2. Okay? And then they told us to express it in this form. So we're going to divide this 4 with the 2 and this 3 root of 2 with the 2. So it's going to be 2 plus 3 root of 2 and then I mean 3 over 2 and then root of 2 like that. So you can clearly see that this one now is in the form of A plus B and then root of what? C. Okay, so that is it for this question. Unless you guys have a question. Do you have any questions? Right, so I said the other part of the test, which is question 2 and question 3, I'll upload it on the website. Okay, so discretelearning.com, that's the website. Or you can also access it from the app. Okay, so the app, just go on Play Store and search Discrete Learning Institute. You're going to find the app. Yeah, Makungu, you have a question? You've raised your hand. You can ask if you have a question.
I just wanted to ask why you've written 4 plus 3, the root of 2, where the 3 is coming from.
Where?
Where that 3 root 2 is coming from.
Oh, okay, I've seen. This one here.
Yes.
Okay, so I've added this root 2, you've seen it here, plus 2 root 2. So this is 1 root 2, 2 root 2. So when I add them, I get 3 root 2. And then this 2 plus this 2, I get this 4.
All right, thank you.
All right, and then you just divide there to get the final answer. All right, guys, so I think that's the class for today, okay? But as I told you, there are many more videos on the website. You can be learning at your own time. Okay, so I'll upload question 2 and question 3 on the website so you can access it from there. All right, so have a blessed night.